No classwork. Unbelievable.
I have a non-related question.
No, I actually like this.
No, stop. I want to get to work. All right. Sure. All right. I need the wrong answer.
X2.
X2. I don't even know.
2x to the x minus 1.
X2 to the x minus 1.
What's X2?
2x.
Oh, X times 2 to the x minus 1. All right. That actually is the wrong answer. All right. And I'm going to convince you that it's the wrong answer, I hope, by, let's see, going, oh boy. All right, so let's change this to 2 to the x, and let's see if what you said was right. You said x times 2 raised to the x minus 1 would be the derivative, and I'll go and I'm going to make the derivative sort of a bold-faced line so we can differentiate it from the function. And we'll go to the graph, and here's the function, and here's what the wrong derivative would be. And I think you can look just graphically at and come up with a pretty convincing argument why that bold function can't possibly be the derivative of the function. Okay, I guess it's ninth period, so we're all calling out, just yammer-yammering. All right, yeah, Morgan, what do you have to say?
It doesn't follow the rules.
Yeah, what are the rules?
When it's positive.
When what's positive? When what is increasing?
When the function is increasing, then the derivative will be positive, and it's negative.
Yeah, what can we say about the function's always increasing, so the derivative should be positive. It's not. So that's the wrong. That was wrong. So we're convinced that that's a mistake we won't make. This gets an x. Okay. Yeah, so this actually, it's not a power function. It's not a function to a power. It's an exponential function, so it needs a different rule. Okay? And I'm going to come up with a convincing argument of what that rule might be, and then we'll get to the point where we put it in a box. So I'm actually going to start with the definition.
Oh.
Yeah.
Oh.
Right.
Oh.
All right.
Are you serious?
So if I start with the definition, the limit as h goes to 0 of 2 to the x plus h minus all over h. Okay. I'm a little stuck, right? I mean, it's not really readily apparent. Like, there's not that, oh, I'll just factor everything out and things will cancel out, right? Needs another strategy. I was going to do this. And you might not agree with me going forward, but would you agree backward that those are equivalent statements?
Yeah.
Right, because when we multiply and have the same base, we add the exponents. Okay. This actually allows me to do something in the numerator. Thoughts or ideas about simplifying the numerator now? David? Pull out. Careful.
No.
Kelly?
Well, it'd just be 2h. Because the 2x and the negative 2x would cancel out.
No dice. Drew?
Yeah, 2x.
2x. I don't see a 2x. You guys are talking. 2 to.
All
All right. Factor out 2 to the x. That's about all I have, right? Factor out.
Can I ask a question?
Not an algebra question. You're gonna break my heart.
I don't.
You can try.
You know, because you're separating 2 to x to the x plus h. Shouldn't you have parentheses around the 2x times 2h?
Well, it's ordered after h.
You can. It's if you want, you can do that. That's fine. Nope. Absolutely not. So I'm left with. You're left with
Basically, when it's multiplied,
this.
it's considered
What did you take out?
two separate things.
Okay, here's the thing. I said it and I mean it. You have to, I'm asking for your attention, right? So when Drew says factor out a 2 to the x, and you're left with the quantity 2 to the h minus 1, I need you all to listen. Like, I'm not asking you to write notes, take notes or anything. I'm just asking you to follow along some algebra, which I would not categorize as incredibly challenging. I would say that maybe it's not like going to be readily apparent that we have to break this up like this, but each step, once someone says it, is obvious. Okay? So I'm now left with something that looks like this. And if you don't believe going forward, do it going backward. What would you do?
Distribute.
You would distribute, right? And if you distribute, can you see that's exactly what you'd get up in the step before? Okay? So, I'd like to say at this point, this 2 to the x, h has nothing to do with it. No matter what h does, 2 to the x is unaffected. Alright? So, I'm actually going to pull 2 to the x out in front, since it has nothing to do with this limit, and it leaves me with 2 to the h minus 1 over h. So at this point, what I'd like to point out is, check this out. The derivative is the same as the function times something else. Right? The function was 2 to the x. What's the derivative? 2 to the x times something. And actually, can you do me a favor? You can evaluate this limit. You can do it numerically. You can't do it algebraically, but you can do it numerically by picking a small value for h. Can you go do that? Like, give you like 20 seconds, pick like 0.01 or 0.001.
Doesn't it basically become 0?
David says it becomes 0. My counter argument would be if this became 0, the derivative would be 0. I know the derivative's not 0. Yeah, that would be a problem. So I don't think it's 0.
No, I'm just thinking if you plug in a really small number.
Do it. Challenge your thought. Yeah.
I have a question just about like when you, is there like a rule that says to pull the 2x out, 2 to the x?
No, it's what.
Or you just like were like, hey.
No, it's clever, right?
Okay.
That's what it is. There's no rule that says you have to pull it out. But when you factor out, wait, sorry, are you talking?
I'm talking about like
to put it out in front?
Yeah.
Oh no. Well, so the rule would be this: the limit has to do with h.
Okay.
2 to the x has nothing to do with h. So I can separate those.
Okay.
That's okay. And yeah, that is like a rule.
Okay.
Like I can do that. So what do we get? 0.69 something? 3? Okay, 0.693. So in other words, the derivative is some factor of the function. And we could take a look. If we actually, instead of doing the wrong answer, if we go to Math 8, and if we graph the derivative, let's see, vars, y vars, y1, comma x, comma x. And here's the function. And now here's the derivative. Now I know it looks like it's below the x-axis. It's just thick. It's not below the x-axis. And the derivative, whoops, does the derivative look like the function? Except what will... Stretched. I don't think we moved it left, right, up, or down. I think we actually compressed it a little bit. Right? We shrunk it vertically. And as a matter of fact, does that make sense? Isn't that what this does? It's the derivative is the function, except stretched or compressed vertically. I think I saw a question. David.
But if you plug in a small number.
Oh, please stop. No, stop. Seriously. You have to stop. Go ahead and plug the small number in, and you're going to get 0.693.
No, I got the right answer.
Good. Awesome. Stop. All right. So if we take a look at the same thing, except we were to look at y equals 3 to the x and its derivative, what would change? Like, if we did all this math out again, what would change and what would stay the same?
The coefficient in the numerator of raised to the h.
I have no idea what you're
Would
saying.
the 2's just change to 3's?
Yeah.
All right, 2's would change to 3. So it would be 3 to the x times, instead of the limit of 3 to the h minus 1 over h, instead of the limit of 2 to the h minus 1 over h, it would be 3 to the h minus. So can you do that? Can you do, and you can probably do second enter, and just change your 2.2 raised to the 0.001 to 3 raised to the 0.001 minus 1 divided by 0.001. What do we end up with?
I got
1.099 or something? I got 3 or 4 people agree. All right, so for 3 to the x, it looks like if I just change this to 3 to the x, I now have the function. And now the derivative, I know it looks negative, but it's not, it's just really thick. Wow. It's almost exactly the same as the function. As a matter of fact, does that make sense? It's actually just maybe a little bit of a stretch. It's 1.099 is the stretch. So look, we know 2 to the x is 2 to the x times 0.693, and 3 to the x is something bigger. Can you imagine that there should be an exponential function where the factor's 1, like the derivative is the function, they're exactly the same?
Maybe somewhere between this two.
Probably.
Yeah. So would it be where the limit of h is 0 equals 1?
Yeah, I would agree. Something to the h minus 1 over h equals 1. I mean, are you looking at this thinking that there might be a number that's closer to 3, that's exponential, that has...
Line. Or e. Yeah.
Dan actually thinks that e to the x might have its derivative as e to the x.
It was on the calculator at the beginning of class.
I don't know it. That's funny. Kelly's not going to let you have this. She's taking your moment and stomping all over it.
That was on the calculator when we started.
Exactly, it looks like that when we got to
That's
class.
what it looks like when we
I wasn't paying
started.
attention.
I'm gonna switch this to the bubble guy. Whoops, I missed the bubble guy. I'm gonna switch him to the bubble guy so that we can see as we do here's the function, and now here comes the derivative, and the bubble guy actually, in this case, is pretty much, whoa, what happened there? I don't know. It's freaking out. It's mad that I've been yelling at you guys today. I don't know. It's karma. That's what it is. It's technological karma. So stop it. So the bubble guy traced on top. As a matter of fact, look at the table. Look at the table of the function and the derivative. It knows that I really do love you guys. They're the same. So in actuality, that's true. Here's a rule for you. Right? There's your box for the day. The derivative of e to the x is e to the x. How sweet is that rule? How's it not a rule?
But why?
It just is. Like, it's not helping us with any other.
Yeah, that's a...
Okay, fine. You don't have to remember it. It's great. Yeah.
I'll use it.
No, I'm just saying, like, how does that help us on other exponential?
Oh, you're saying that's so specific.
Yeah.
What if it's like 3 to the x?
Yeah.
How am I supposed to figure out? All right, that's a good question. Yeah, where do these come from? These factors, and I probably could have written, isn't there a 1 factor of 1 there?
Oh, I think
You want to give it a shot? It's tough. It's a tough one, but you want to give it a shot?
Well, wait, what am I answering again?
I'm trying to figure out if I didn't want to write these as a decimal number, is there some way of writing this that would be easy, would be a shortcut that Morgan wants? Morgan's saying do I really have to remember it's 2 to the x times 0.693? Isn't there a better way of writing that.
Log of ln
You could,
of some kind.
maybe.
Because I'm thinking ln of e to the x.
Oh, it's the ln of the coefficient. Yes,
Your use of the word coefficient's
the
wrong.
two,
That's called the base.
the base, there you go.
Okay. So Dan says that it's 0.693.
The
Oh my
ln
god,
of
that's it.
That's ln of 2.
There we go. See, that's what I was talking about. See, now I can use that on another problem.
You are
Okay.
good, Dan.
I agree.
You are good.
All right.
Dan, you're a genius.
So Morgan,
Yes.
if it's a to the x, then the derivative would be
ln ma.
Did Morgan just make up her own rule?
A raised to the x.
times
Times. Wait,
A
what?
to the x.
Yeah.
a to the x.
Wait, it's a to the x.
Right? What was the derivative of 3 to the x? 3 to the x times the ln of 3. Right? So it's actually a factor times the function. And would you, Morgan, you're saying actually if you just remember this second rule, you actually don't need the first rule. Is that true? Because if it was e to the x, it would be the ln of e, which is
Just one.
1 times e to the x. All right, good. So there's the exponential rule. And so here it is. Here's the reason why we spent time trying to convince you that using base e last year could be simpler. And it's because when you take the derivative of something base e, it's just itself. You don't have to remember to add on another little constant. Can you see, though, if actually, if like we did things in base 10, it wouldn't be that bad? Like 10 to the x would just be the ln of 10 times 10 to the x. Not that big a deal to find the rate of change of something. But if the rate of change is exponential base e, the derivative's super easy. It's just itself. How awesome is that rule? Don't have to work too hard remembering it. Rachel, and then we should practice.
I think I missed something, because I get how it's the derivative. Oh, wait. Okay, no, I figured it out. It's just
Awesome.
the ln of a and the ax.
Oh, do you want me? You know what? We did that in the other class. We actually said that the derivative was a to the x times ln of a. Do you like that better?
Yeah, well, yeah, because that's the way
Sort of fits the pattern.
Yeah.
Okay.
Question.
Yep.
You just like pull that, like out of the blue, like that ln stuff.
Well,
Or it's just, is it just?
I didn't pull it out of the blue. We looked at this limit and it's a decimal, and we could probably do a little bit more math, maybe not this year, but to actually prove to you that this is the natural log of 2, that limit is. I would agree with you. We saw a pattern. Dan made a guess, and we saw that his guess was true at least twice, and I'm going to tell you that it's going to be true all the time. All right? Dan, and then we need to practice.
Does this work if you like raise something like the 2x or like the
Raise something to the 2x.
or any other coefficient?
It gets a little more complicated. It does work. We're actually going to see how. Actually, here, let's do this. I'm going to write it like this. Isn't that the same as raising it to the 2x? Okay. So the derivative here would be, well, the rule for an exponential is the function itself, right? So it would be e to the 2 to the x times ln of the base, which would be e squared. We actually know what the ln of e squared is.
1.
I like 2 better. Ln of e squared, not ln of e. The ln of e squared is 2. So in this case, if it was e to the 2x, the derivative would be 2 times e to the 2x. This is 2. We just said that that's 2. You guys really don't like things written out of order, I guess. And likewise, if we did e to the 3x, we would get e to the 3x times the natural log of e to the 3. Well, this we just know is 3, so the derivative would be 3e to the 3x. So it's a little different. Like, it's not just, you can't say the derivative of e to the 2x is e to the 2x. It's e to the 2x and then there's something else going on. and we need a couple days before we figure out why that's there. All right. David thinks he knows. All right. Rachel, and then we need to do practice.
Can you do the power rule for the
No.
E squared?
No. What's e squared? That's a constant. That's a base. It's not like x squared. Okay.
I don't get it.
But Rachel, I see what you're trying to get at.
Here, think about this. What's the derivative of smiley face to the x?
Smiley face. There's yellow and smiley face.
Okay. So isn't just e squared? Isn't e squared just a big smiley face?
Yeah.
Okay.
I understood it until we did this, and I don't know. It's the same thing.
It is. We should practice.
Can that be a problem?
That could be that one on the end that you can't get wrong.
No, because somebody probably would.
I really have a big one.
Are you kidding me? All of them.
No, it actually took me a second.
Yeah, exactly. Alicia, you saw it, you were like, crap. You watch that episode. I was really happy when I saw that on the test. I was like, yes, I always watch Simpsons. I was like, oh.
All right. David.
Alright, is that NC plus C?
You got it.
Oh, mix it together.
All right, David, who's up?
Anybody? Go ahead.
Okay, I'm just going to track. So would it be 12 to, hold on, 12 e to the x
Yep.
times the ln, or,
You could do that times the ln of.
12.
No.
I mean,
What's the base for 12? Mm-mm. E is the base. It's not 12e quantity raised to the x. E is the base. So it's 12 e to the x.
Oh, okay.
Plus.
Plus 11 to the x times ln of 11.
Yep.
Why did
Who's up, Morgan? No, can't do backsies.
I know.
Alicia's saying she'll do it. Perfect. I love it. All right. Rachel saw power rule. She didn't get faked out. She knew that e squared was constant. What did I just say?
Rachel?
Sorry. Perfect. Alicia, I'm sorry. I was looking right at you. Yes, definitely. Alicia saw the power rule, didn't get faked out. No exponential rule in there. Nice. Alicia, who's up?
Rachel. You can do it in my mind. I paid for it. Is pi times pi is just a number, so
Yep.
it goes away.
All right.
And then 2 to the pi is just a number.
All right.
That goes away. And then pi to the second is just a number, so that goes away.
So what's the derivative?
Well, a number. Zero.
What's the derivative of a constant? 0. Yep. Good. Nice.
Yeah, Rachel.
I love to eat pie. I hate that a lot.
No, absolutely not. No.
What? No, the other day, one of our homework
All right. So maybe here I'll give you one homework problem. All right. 5. Who's up? Drew.
The derivative is 2 plus 2 to the x times ln.
Hold on. 2.
Yeah, 2 plus 2 to the x.
2 to the
ln.
All right. So I'm liking the 2 to the x times the ln of 2. Yeah, see, class. This class doesn't like things out of order, but not just 2. 2x.
Oh, my bad.
All right, so 2x. And other people might like it better if we wrote it like this. I've learned this today.
Wait, hold on. Wait, do you care what number now I'm...
No, they're both the same.
Yeah.
Those are exactly the same. What's the what's the derivative of ln of 2? ln of 2 times, sorry. What's the derivative of 2 to the x? 2 to the x times the ln of 2. What's the derivative of x squared? 2x. What's the derivative of pi? 0. All right. 5 times 5 to the x. Kelly?
Isn't that just 5dx times
I got it.
All right.
I just figured it out.
All right. Hold on.
Sorry.
I will call on you. This is what I would say, Kelly. If this was the derivative, then that would be, whoops.
Right.
Then that would be the function.
Yeah.
All right. But that's not the function. David?
Derivative 0?
No, definitely not.
What the... Wait.
No.
Why was the derivative
Kelly?
0?
The derivative of the constant is 0.
It's not constant.
Oh, well, that's not be rude.
5 is 1.
No, you don't.
Well, plus 1.
Well, what did we do? I mean, back when we did this, if I gave you x squared, you would tell me the derivative is 2x. If I told you the function was 3x squared, you told me it was 3 times 2 to the x, right? So the constant out in front, remember we talked about this? What does the constant out in front do? It just stretches the function. So 5 just makes the function 5 times steeper. So what should the slope be? 5 times steeper. So where do you want me to put the 5 so I don't mess this up? Okay. Oh my gosh. Picky class.
So you can't do 25 to the x?
No, definitely not. That'd be horrible algebra. I'd send you back to 8th grade.
You know,
I would.
you can blame it on benchmark. It's not everything.
All right. All right, what do we have? It's like a smiley face. Ian, it's like a smiley face. Come on.
The answer is smiley face.
It's not.
The answer is smiley face to the x times the ln of smiley face.
It is. So go back and substitute in for smiley face.
Wait, are you?
You're right. Go ahead.
ln of 2 to the x times
ln of 2 to the x times.
the ln of b.
Yep.
You can do that.
You certainly can.
Do the ln with just numbers.
No, they don't. There's no way really to simplify the natural log of the natural log of 2. All right. Yeah. So there it is, right? And this is a very, like, Ian said it and we sort of laughed, but he was right. The derivative of smiley face to the x is smiley face to the x times the ln of smiley face. And that works. Like, so if you can think about in those broad, so you need to be able to do both, right? Do the nitty gritty details, but also think about like the big picture rule. Yeah, exactly. All right. From last night, 1 or 2 questions. What do you want? 37? One thing at a time. One thing at a time. One thing at a time. So I'm just going to write it like that. So instead of writing it as x cubed over a, I'm going to do 1 over a times x cubed.
Wait, what number is this?
37. Yes.
And now 1 over a is just a coefficient, right? So the derivative of 1 over a times x cubed.
Oh, it was 3 over a x
Okay, so I'm going to say 3 times 1 over a, but you can do 3 over a. That's just the next step. X squared plus 2 times a over b x minus c. And you can simplify that if you want, right? You can make that 3 over a x squared plus 2a over b x minus c. But the important thing is get out of that division, right? That x cubed over a looks like a quotient or something. Get. You wanted to do.
The numerators by themselves?
You want to do 3x squared over a?
Yeah, just like fix the numerators.
You can do that because a is a constant. Now, if a is not a constant, it's different, but you can say 3x.
The numbers, yeah.
Yeah, so you can do 3x squared over a, and that totally works. 2ax over b. Okay? Rachel.
Yeah.
You had one. V equals 4/3 pi r squared b.
Yeah.
And in terms of r, so dv dr. All right, so r is the variable. Let's see, exponent out in front, so that's 8/3 pi r b, r to the first.
Oh, it's just the way the book wrote it. Okay.
Leibniz notation.
Yeah.
Derivative with
Pi r b over 3.
Okay. Oh, they wrote the answer funny. Okay.
Oh.
Morgan?
Wait, time out. Sorry, I'm just confused. So the V, that's the actual, but the V equals 4 over 3 pi r, blah, blah, blah.
That's the equation, and it wants to know what the derivative is. It's asking what's the derivative.
That was throwing me off.
So find dv dr, the derivative with respect to r of this function. So that's what I was asking.
I have a
Yep.
question. Could you simplify 4/3 pi and then put into like a number and then do 2 times 4/3 pi r?
Yeah, sure. You know what 2 times 4/3 pi is? 8/3 pi.
I know, but
I mean, you can. All right. Before you before you end up